Good morning everyone. I am Rehana Anjum. Currently I am pursuing my first BTech in Srinivasa Ramanujan Institute of Technologies in Anantapur. Now I am going to talk about minimum values and minimum value related problem. The problem is find the minimum value of x square plus y square plus z square given that x, y, z is equals to a cube. So let us know what is meant by minimum functions of two variables. Let f of x comma y be a function of two variables x comma y at x is equals to a, y is equals to b. F of x comma y is said to have maximum or minimum value if f of a comma b is greater than f of a plus h comma b plus h, or f of a comma b is less than f of a plus h comma b plus k respectively, where h comma k are small values. Here h comma k are small values. And now let us know what is meant by Lagrange's mean of undetermined multipliers. Suppose if it is required to find the extremum for the function f of x comma y comma z subject to the condition phi x comma y comma z equals to 0. Step 1 is from the Lagrange's function f of x comma y comma z is equals to f of x comma y comma z plus lambda into phi of x comma y comma z, where lambda is called the Lagrange's multiplier, which is determined by the following conditions. The conditions are, and the step 2 is obtain the equations dou f by dou x is equals to 0, that is dou f by dou x plus lambda dou phi by dou x equals to 0. Dou f by dou y is equals to 0, that is dou f by dou y plus lambda dou pi by dou y is equals to 0. Dou f by dou z equals to 0, that is dou f by dou z plus lambda into dou pi by dou z equals to 0. And the step 3 is solve the equation 1, 2, 3 and 4, which gives the stationary values of x comma y comma z. By solving these 4 equations, we get the x and y z values. And here note is to find maximum or minimum for a function f of x comma y comma z equals to 0, subject to the conditions phi of x comma y comma z equals to 0 and phi of x comma y comma z equals to 0. From the Lagrange's function f of x comma y comma z equals to f of x comma y comma z plus lambda phi of x comma y comma z plus mu of x comma y comma z, where lambda and mu are the Lagrange's multipliers, and proceed as above. So now let us see these minimum value related problem. The question is find the minimum value of x square plus y square plus z square given that x, y, z equals to a cube. We have to find the minimum value of these related equations. Now let us see the solution of the related question. Here these equation 1 and 2 are given in the question. So f of x comma y comma z equals to x square plus y square plus z square is the equation 1, and phi of x comma y comma z equals to xyz minus a cube is the equation 2. From the Lagrange's function f of x comma y comma z equals to f of x comma y comma z plus lambda phi of x comma y comma z. Here f of we have to substitute f of y comma x comma y comma z equation is x square plus y square plus z square plus lambda of x y z minus a cube is the equation 3. Now dou f by dou x equals to 0. Dou f by dou x means 2x plus lambda yz equals to 0. From these 2x plus lambda yz equals to 0. From the above equation we get lambda is equals to minus 2x by yz. From this equation we get minus lambda by 2 is equals to x by yz is the equation 4. Dou f by dou y is equals to 0. From these 2y plus lambda xz equals to 0. Lambda is equals to minus 2y plus xz. Lambda minus lambda by 2 is equals to y by xz is the equation 5. Then similarly we have to do dou f by dou x. Dou f by dou y is equals to 0. 2z plus lambda xy is equals to 0. Lambda is equals to minus 2z by xy minus lambda by 2 is equals to z by xy is the equation number 6. Now from the equation 4 and 5 we get xy by yz is equals to y by xz. Here z and z get cancelled, then we get x by y is equals to y by x. By cross multiplying these two equations we get x square is equals to y square. We can write this equation as x is equals to y. So this is equation number 7. From equations 5 and 6 we get y by xz is equals to z by xy. Here x and in this equation x get cancelled. By cross multiplying these two equations we get y square is equals to z square. From these we get y is equals to z. We can consider y is equals to z as equation number 8. From the equation 7 and 8 we get x is equals to y is equals to z. So the given is x y z is equals to a cube. X cube is equals to a cube. Here y and z are x and x y z both are these three are equals. We are considering as x, these two as x. Here x into x is equals to x cube. So x cube is equals to a cube. From these we get x is equals to a. Similarly, when we substitute y and z values in the given equation, we get y is equals to a, z is equals to a. Then we get x equals to y equals to a. From these f is equals to a square plus a square plus a square. By adding these three a squares we get f is equals to 3a square. Here f has minimum of 3a square. So this is about the minimum value and minimum value related problem. So thank you for this opportunity.